daily time series of the aerial extent of the 850 millibar cold air pool. That is air colder than -5°C over the Northern Hemisphere, as measured from the GFS 1 degree analysis every morning. I do it every 6 hours, actually, and then take a daily average. And that's what I use to construct this chart. So the individual chart all by itself doesn't tell you much. I'll have to fill in some details. This is the 9th warmest year in the 73-year NCEP time series. And that means warmest in this case means smallest aerial extent integrated over the whole season from December 1st to February 28th. So we've had 8 warmer winters, but many of them were in the last decade. So it's been an incredibly warm decade in this regard. And I think that's worthy of some note. February in Madison was officially 10.7 degrees below normal. And that is the first time that a month has been more than or equal to 10 degrees below normal since the famous December 2000, when we had, I think, our coldest December of all time and 4th snowiest. I may have those reversed. It might be snowiest, but 4th coldest. Anyway, it was an incredible month for any of you who lived here at that time. Boy, was that something else. It turns out that since 1940, there have only been 12 months in Madison's weather history that have been 10 degrees or more below normal. And 11 of those have occurred in DJF, 5 of them in December, 4 in January. This is only the second February ever that did that. The last one was February 1979. And one time in March, which happened also to be March of 1979. So 2 straight months. I think that's the only time that's ever happened in Madison was February and March 1979. So we had a pretty unusual February here, but February was kind of characterized by a rapid dip in the aerial extent of the cold air, and we set an all-time record. These thin blue lines indicate on the bottom the minimum all-time aerial extent, and on top of each blue line is the maximum over the whole time series. So we set a record on the 7th and 8th of February. That was pretty neat. And let's see, what else was I going to tell you about that? I think that's about it. And I'll say one more thing just to kind of get away from the wintertime discussion here. I'm going to do some more on the winter in just a minute, but there's a chance, at least people were talking about it earlier this week, a chance to see 60 degrees Tuesday. I think those chances have receded. And were we to get to Tuesday, we've been 106 days in a row now since our last 60 degree Fahrenheit. That was November 19th. But the all-time record is 173. And that ended on the 11th of April, 1958. We're not going to get to 173. We don't have 67 more days of temperatures below 60, but we probably do have 5 to 10 more. I don't think we're going to do it on Tuesday, but I'll leave that to the forecast. So let me move forward and show you a few other things about cold pool history, not just this year. What am I doing here? Oh, yeah, I guess I'm out of there. How come I can't advance? Oh, there I can. Okay, sorry. This is, I took away the gray shading in the long-term average and the solid blue, just to give you an idea what the 1950s looked like on this same chart. And so that's the 1950s, all 10 years from 1950 to 1959. This is now the 1960s, and I leave the 1950s behind in the gray, and I'll do that with each successive decade. So the 1960s were generally colder all the way through the winter months than the 1950s in this time series. That's kind of interesting. It's also true that the 1970s were warmer than many of the times during the 1960s. It's not entirely the case, but in many of the instances, calendar days, that was the case. In fact, early February in the 1970s was way colder than it was in the 50s and 60s. Then when you go to the 1980s, you start to see this is where the depression in these aerial extents begins to occur in earnest and does not look back. 1980s, as you can see, are colder almost everywhere than the 1970s and in many instances the 60s. The 1990s are the warmest month of all, the warmest decade of all time up to that time, far below in aerial extent of the cold air than anything that had occurred in the prior 4 decades. And that continues in the 1990s, the 2000s, and then the 2010s. So there's a steady decrease per decade of the aerial extent of this cold air from December 1st to February 28th. And that's a pretty unmistakable sign of the global warming that's occurring around the globe. You're eating away at the edges of this cold pool by infrared retention that has been increased since 1980. Let's see, I'll go back to the 1980s, or since 1990. We've had a 2.5 times 2.5 times the increase in carbon dioxide fraction that had accrued from 1960 to 1990 has accrued since 1990 to 2020. So we have an incredibly rapid, almost 2.5 times rate of increase of carbon dioxide parts per million in this 30-year period that's ending right now. So pretty bad news for us overall. So I think I'll move on to the regular part of the discussion. So I'll stop sharing this and then share another part of my screen, which is right over here. Yeah, okay. And let's see, I'll get back to I can't even see through all these various things. So let's start with the satellite movie over the continental 48 and adjacent waters from this morning. And you can see there's a really set of interesting different scales of the disturbances that you can see across this broad panorama. First, the one that's up over the Canadian Maritimes, in fact, well to the northwest now of Newfoundland, is an extremely large-scale cyclone. You can see cloud elements associated with it all the way down into the Caribbean on its far southern edge. And then there's clouds being raked across the southern part of the Greenland ice cap that's quite clear in this infrared satellite image on sort of the northern periphery of this big disturbance, which is circulating somewhere around Labrador. So a very impressive in terms of its scale, extratropical cyclone, and it dwarfs in size the little midget storm that's kind of over the panhandles of Texas, Oklahoma, and then moving eastward into Missouri and Arkansas, although that one is associated with a fairly widespread, not apparently too convective of a precipitation. So we'll see a little bit about that disturbance as we move forward in the discussion too. And then obliquely only at this angle, and I'll show you in a minute a less oblique angle of this disturbance that's beginning to spew clouds mostly into British Columbia and the Pacific Northwest of our own country, coastal Oregon and Washington. But you can even at this angle see the popcorn cumulus that's back behind here, and wait till you see the temperature of the air there. It's really, really cold at 500 millibars. So I think what's happened this week, and I haven't had time to really do an investigation of the nature of this, but I think we had a really substantial cold air outbreak over the Gulf of Alaska. You know, the ones that attract attention, cold air outbreaks that is, are the ones that occur over land because the air doesn't get modified and there's a lot of people living there. And so there's impacts, as we saw a couple of weeks ago in Texas, and they're still not done with the impacts in Texas. Poor people down there are still suffering, but they won't even wear masks. But that's a whole nother issue. You know, I mean, it's just amazing how they're being governed by kindergartners. But you know, I have to say that I'm so upset and frustrated by it. But here's the cold air aloft, and wait till you see the temperature on that. So we'll move forward and do that in just a second. Okay, here is a broad picture of the landscape of the North American continent and the adjacent waters in terms of sea level pressure in the black lines. This is from Alicia Bentley's wonderful map suite. And then she has the 250 hectopascal wind speed shaded in there as well. As you can see, and I'll say more about that in a minute, but you can see that the maximum across Texas and the southern states has a link all the way across at 20 degrees north to the eastern Pacific. That's clearly a subtropical jet, and then it's got a whole bunch of waves in the polar jet to the north. And so giant anticyclone sitting over northern Canada with central pressure of 1,048 millibars to the northwest of Hudson Bay, far northern Manitoba and the archipelago, and that's sliding southward along the thermal wind right across the Great Lakes region. So that's going to keep the skies clear for us, I think, for several days in a row as this happens. And then there's punches of cold air that we may experience in the next week, especially late in the week. I think our benevolent march to this point really been quite remarkable. We've lost a huge amount of snow without puddles everywhere. And that's because the air has been dry, the sun's been out, so there's been a lot of sublimation, not so much puddling and rapid melting. And that's nice to go from 15 inches of snow cover to whatever we have left without lots of puddles is quite remarkable. But it's a function of this persistence of anticyclonic activity over the Great Lakes states and the northern plains, which we've enjoyed since March 1st. And then on the West Coast, you can see about 992, 998 millibar low right off the coast of Washington and Oregon. That's the one that we'll see in the satellite in just a minute. And that's the first in a series of waves. You can get a hint of that as you look back to the left on this diagram. And then there's the big scale cyclone. It's not particularly intense. It's only about a 984 millibar low, just to the north of the St. Lawrence Seaway. And that is, but it's large in scale, as we just saw. It has cloud elements down to the Caribbean and cloud elements raking the central part of the Labrador Sea. So it's a pretty intensely distributed cyclone, but not particularly intense anymore at this time anyway. So here is the radar over the continental 48 this morning, and there's our disturbance. It's really just the last 5 hours. There's our cyclone in the just north of the Red River Valley in Oklahoma, parts of Arkansas, Louisiana, and southern Missouri, the Ozarks of Missouri. So it's raining in all those places. It's far warm enough to be raining for sure. And that's the case associated with that small scale disturbance. And then here's the precipitation coming on shore finally. It's been mostly parallel to the coast for several hours this morning, and now it's made its way on shore. It's raining probably moderately in Seattle and all the way up the Puget Sound, up to Bellingham and into British Columbia. And then it's raining in Northern California, and there seems to be a gap. It might just be a radar gap in this a rather unpopulated portion of the Oregon coast. I'm not sure about that, but because it looks continuous in the satellite. So raining in the Pacific Northwest in association with this storm that is off the coast now. And I want to show you a better view of that with this satellite movie. Is it not animating? Let's see. Maybe it's started. Okay, there it is. So it's really, there's two storms right next to each other, kind of going up the British Columbia coast, it seems to me. The first one is this much smaller scale north of the former Queen Charlotte Islands. And that's a smaller scale disturbance. Doesn't seem to have as much potency either, nor as much cold air ingested into its western side. But there it is nonetheless. This is the more impressive storm, which has really a widespread popcorn type cumulus, open cellular cumulus clouds on the southern side of it. And they're widely spaced. And every time I see when they're widely spaced, it makes me think that the convective updrafts are intense and therefore the downdrafts are more widespread, though benign. And that's what gives the open space. So it's usually the spacing between these things is a pretty good indicator of how cold the air is aloft at 500 millibars. So when I saw this morning, before I even looked at the map, I thought, wow, this might be as cold as minus 35 or something at the latitude of Northern California. And you'll see in a minute, that turns out to be right. So this is very cold air aloft. And then here's another disturbance, which unfortunately we only have not as oblique an angle as the prior, continental view on the West Coast, but slightly oblique here in the southern Bering Sea. This thing is evolving into a cyclonic disturbance out of, I think, a collection of convective elements, sort of what happens in some instances in polar low development. This thing may have had a little cohesion even at the beginning, but it's really cold air over the Bering Sea. I mean, this is really, really cold, and you can kind of see that just in the nature of the clouds as they appear on the satellite. So that's pretty dramatic. So that's the overview of what's happening around the continent. Let me show you now some upper level charts that go along with this. I always like to start at 500 millibars just because I guess I'm thinking about what the cloud elements look like out over the Pacific. But this is from 12Z this morning, and look at that. Minus 37 is the analyzed low temperature, but that's the minus 35 isotherm at 500 millibars in a deep upper trough with a couple of little disturbances along it. There's one here in the British Columbia coast that's cyclonically curved, and the stronger cyclonic curvature max at 12Z anyway was just off the Pacific Northwest coast. And that's when the storm was just beginning to make headway into the Washington, Oregon coast. It's now firmly embedded there, and the whole system has probably moved to the east. And then out over the Bering Sea, look at the temperatures you see here. I don't know the name of this island, but it's off the coast of Alaska. Minus 48 degrees, I think it says, or minus 43 at 500 millibars. Evidence, again, of desperately cold air coming out over and don't forget, the Bering Sea is shallow. So it's a shallow, big lake effect sort of event up there right now, and shallow lake, that is. And so I'm sure the seas are heaving in the face of these storms, and it's cold and it's convective snow. It must be miserable to be out there today if you're a mariner or a fisherman or something like that. And notice also how intense the upper baroclinic zones are on the southern side and western sides of both of these troughs. This one here is the predominant one, really intense upper baroclinicity. This isotherm is the minus 20 degree isotherm. So you've got almost 20 degrees at 500 millibars of thermal contrast from the coldest portion of this upper trough to the warm side of it. And there's even a warm bubble here, and that indicates, whoa, you've got some subsidence probably occurring locally to make that happen. I'm going to show you a cross-section from tropical tidbits that goes right through that thing at 12Z. We get a nice picture of it in a minute. And here's yet another. Sorry, go ahead.
Sorry, John. I was just, I don't want to, maybe you want to finish that point, but I have just something about the larger scale on this map.
I was just going to say one more thing about this, and that is there's another extraordinary baroclinic zone, maybe not quite as tight as the one to its south and east, but it's pretty intense, and it's characterized by strong cold advection and cyclonic shear. So it's likely to get stronger. In fact, this isotherm, if it were drawn by hand, I'd have more confidence in it. This -20 has this little cleft that goes up and kind of meets this gradient. And that indicates to me that there's probably maximum sort of subsidence going on there. That's where the upper front's becoming most intense from that look at that analysis. And then one last comment is this disturbance is more intense at 500 millibars. Look at the minimum height there. It's 4960. That's below 5,000 meters. And I don't think that's too common so close to northern Maine. So that's why that disturbance has the appearance that it has on the satellite. This is like the great red spot for the Western Hemisphere right now, but it won't last, of course, like that one does. And it's a cyclone. But nonetheless, it's a pretty deep, intense disturbance. And but it doesn't look quite like that at sea level. It's only like 987 millibars or something at its core. So I think this is now in its late stages. It was probably more impressive earlier in the week. And then in association with the radar activity that we saw over Arkansas, Oklahoma, parts of Missouri, and Kansas, here's a very weak wave. It has no upper level thermal contrast really to speak of at all. It's just a really potent cyclonic disturbance at 500 millibars. We may see a little bit more structure to it at other levels, and we'll take a look in just a minute. But Michael, what was your comment?
Right. One was just the scale of that vast sprawling cyclone over eastern Canada and the upstream ridge as well. And that just portends to us that the weather patterns are going to change rather slowly over the next couple of days. It's not going to be a rapid change just from Rossby wave dynamics. It's a really large scale pattern. You're not going to expect significant shifts. The other was the upper front on the western side of that over parts of West Virginia and North Carolina, not West Virginia, sorry, over Pennsylvania.
Oh, yeah. That's
a pretty intense one. And I was just thinking, as you were pointing out, the stronger upper fronts that are evident up over the Pacific, for this particular disturbance, the eastern, once you get off the East Coast into the Atlantic, that gradient is nothing to get particularly excited about. But when you know that really intense gradient over, from Southeast Michigan to Salisbury, Maryland, is that of any significance in your mind in terms of what might be happening in the next few days going forward? I'm asking that with total ignorance at this point. Does it get you excited about there's something that might be about to happen with that jet stream?
A little bit. Yeah, a little bit. I like to see, because I imagine that if I didn't get a cross-section prepared through that, it would be interesting to look at it. We might be able to do it on the fly. That's going to be a local depression of the tropopause right in this region, no doubt about that. And there'll be a front edge to that depression, and that means there'll be a front edge where there's a strong PV gradient, either on isentropic surfaces or isobaric surfaces, however you want to look at it, which means in turn that there'll be some differential vorticity advection, probably out here over the North Atlantic, but southeast of Massachusetts. And that's a region where the stability is likely to be low, pretty low right now, because I think that's post-frontal from the main disturbance up over maritime Canada. And the ocean water is pretty warm there. So you've got a combination of weak stratification, probably some forcing. The question about how potent and how focused it is a little bit open, because I haven't seen any of the analyses, but your point is an excellent one. There's a dynamical feature of substance that's making its way over a region that could be quite susceptible to development. And so I would look for that. In fact, I'm not sure we didn't see something like that going on right out in here, right? Some little bit of, I guess that's too far out away from the upper front, but out in this region, I wouldn't be surprised if that's where you see a little bit of development today. And so cloud tops getting a little higher, maybe colder, maybe some circulation starting to make its appearance in this portion, because this will be the most polarly stratified air of the whole column, I would think, and closest to the upper disturbance, and then over relatively warm water. So it's not impossible that something interesting could happen there. I haven't looked forward to see that. So it's a good point.
Thanks, John.
Yeah, sure. Let's go to another level. Let's go to 300 millibars first, perhaps. And that's 12Z this morning, 300 millibar. So here's a hint of that subtropical jet. It made me think I want to see what the 200 millibar level is, and we'll show you that in just a minute. So here's that wind coming across at 30 degrees north latitude, and then a lot of waves. And each of the waves has some sort of intense wind speed associated with it. This one out on the west coast more intensely and more symmetrically than the larger scale disturbance out here. And as Michael just pointed out, here's a local wind speed maximum at 300 millibars that is exactly coincident with that 500 millibar temperature contrast. That's probably a really decent looking upper front. And it may well have something to say about weather developments here in the Gulf of Maine later on today and into the day tomorrow. And let's go to maybe 850, just to get an idea what the low level thermal contrast is associated with this whole thing. So as Michael pointed out, at 500 millibars, the eastern side of the big disturbance over maritime Canada doesn't have a really obvious and well-concentrated baroclinic zone at 500 millibars. That's not at all surprising. It's rare to see such a structure. So when you look down here at 850 and you see it's also not very well put together, it makes you think that there's been a lot of modification of the air over long residence time over the water. Even with that, there is a thermal ridge that's warmest air is over 10 degrees at 850 in this plume that's headed, poleward. And then there's just a consistent, almost consistent gradient all the way back into the depths of the cold air. It's just that it's not particularly well concentrated. And the lack of concentration is partly kinematic. This is just a broad vortex structure, and vorticity without deformation can't really concentrate temperature contrasts. And it looks almost like a pure vortex in some ways. It'd be hard to really see by eye the deformation fields in the vicinity of this region, or this disturbance, sorry. And so that makes it hard to produce a frontal structure as well with that one. And then here's our weak storm over the Red River Valley, and there's not much thermal contrast associated with this thing, even at 850 millibars. Look at this. At Shreveport, it's 8, and it's 8 at near Kansas City. And so there's not much temperature contrast around the eastern periphery of this. And it doesn't get that much colder. Even on the northwest, it's 4 degrees at Dodge City. So 4 degrees at Lubbock, that's not particularly cold. So it doesn't really have much thermal structure. And our storm off of the Pacific Northwest has a little bit more obvious cold frontal structure here. There's at least 2 isotherms, so at least a 5-degree temperature contrast over this short distance off the California coast, and it starts to get shredded a little bit by its interaction with the high terrain of the Pacific Northwest. And then remember, we had a second upper trough that seemed potent and ready to do some damage, developing weather systems. There was something that seemed to be developing near Kodiak Island, and that has a very intense 850 millibar temperature contrast with deformation in the flow. And so it's able to stay a little bit more put together. And then one last thing, there's a really nice warm bubble here over the high terrain, not the high terrain, downstream of the high terrain in Prairie, Canada, and some of the Northwest Plains. That sets the stage for us to experience a decent warm up on Sunday and Monday, because we have some adiabatically warmed air as it comes southward, comes across the high terrain. So that's something to look forward to for us. So the last thing I want to do is show you the 12Z analysis over the Pacific Basin. So this is sea level pressure, and it's tropical tidbits, so it's drawn every 2 millibars. If hurricanes are the most intense storms in the world, why do you got to draw them at 2 millibars? If they're so intense, draw them at 8. We'd still see an intense storm. So anyway, tropical's got some revisions to do, if you ask me. It's a little soapbox. So the black lines are isobars, and then 500 millibar geopotential heights are shaded. And I want to show you a cross section that I've drawn from up in the northeast corner of British Columbia, right through the cyclone. But the reason I was doing it is I wanted to get through that cold pool and get into that upper frontal structure that's back in this portion of the upper trough. First, before I do that, I've got it already drawn. I just want to show you, look at how intense this cyclone is at 500 millibars over northeast Russia. This is really cold, and this is probably the reason why there's been this succession of small, little bit potent disturbances, because there's cold air being pushed southward out of underneath this really cold upper low and over the Bering Sea. So there's cold air outbreak over the Bering Sea. So let's take a look at this cross section now. and it's right through there. And look at this. This is PV. So the black line is the 2 PVU isotel. It comes all the way down to about 750 millibars, I think, without argument. And then here's the isotax in purple, and the isotopes are in green every 5 degrees Kelvin. So this is an extraordinarily strong upper front. Look at this. This temperature here is on the back side is 290 Kelvin. And then on the warm front side, it's 310. So 20 degrees C at about 500 millibars, as we saw. And there's extraordinary horizontal and vertical shear in there that we couldn't see so obviously in the plan view. But this is a really nicely developed upper front with a deeply penetrating PV pendant out of the stratosphere. In fact, if you went to contours of only 1 PVU, you might come all the way down to about 800 millibars here. So this is really one of the better upper fronts I've seen in an otherwise innocuous looking upper trough structure. It's just a really strong cold air gradient at 500 millibars, but it's part of a deeper and more interesting structure. So this thing itself, as it rotates around the base of this trough, could bring continued unsettled weather to the Pacific Northwest. I wouldn't be surprised if that's the case for their weekend. So that's what I have for today for the current weather and some of the observations of it. And I guess I'll stop sharing my screen and unless there's questions. Okay, I guess I'll stop then. Thank you.
Okay, thanks, John. And I'll start sharing here. I hope I get this right. Let's see what you're seeing. Okay. Sorry, make sure I'm on the right, the correct desktop. All right, yeah, we're good. So what we're going to do today is look at the weather over North America over the next, or not over North America, but over the US and over our area for the next few days. As I mentioned during John's discussion, when you're showing the 500 millibar analysis, we have this broad sprawling anticyclone that's located over eastern Canada, as well as a broad ridge over Western North America. And that pattern with this very long wave length pattern or very small wave number is one that suggests things are going to be slow to evolve. And so we're not going to expect big changes in our weather over the next couple of days. But one of the big questions is, will we warm up? And we'll take a look at that when we get into midweek. Start off again with John's favorite map or chart, the meteorogram. And also, before I begin, I'm going to say one other word about John's, he had to mention tropical cyclones and hurricanes and the contrainterval on tropical tidbits. Mm-hmm. Two pieces of sort of weather news, weather-related news that you might find interesting. One is the hurricane season is now moving up the date when they start their tropical outlooks. These are discussions of weather features in the tropics that may develop into tropical cyclones and then obviously be worthy of considerable attention. And they move that up for the Atlantic from the 1st of June to May 15th. Contrary to what you may have heard, there was a consideration about moving the start of the hurricane season up by 15 days to May 15th as well. But that was something that they considered, but chose not to do that. And the reason they considered moving these things, they've moved at least their tropical outlooks up by 15 days, is because they've seen over the last decade many tropical cyclones beginning to develop in the month of May. But I guess they didn't see it as big enough concern yet to begin moving the start of the season up. But that's something that's kind of interesting. In our lifetime, seeing that shift in interest a little bit earlier. Yeah. Although that interest in tropical cyclones could be around for all times. I'm sure John would agree with that. Second thing, weather related. I'll just talk right over it. Talk right through it, John. The second thing, and I also realize I don't have my video going. The second thing is the fact that we also, the Weather Service is going to discontinue their advisories. So now it'll be just watches and warnings. And this is going to happen over the next few years. I think it's about 3 to 4 years from now. Sort of weather advisories, winter weather advisories, things of that sort are going to be discontinued. And the reason they're going to do that is just they want to have more plain language, plain text discussions of what the weather hazard is, because there's a confusion. Working with the social science community, they found that there's a confusion between what's a watch, what's a warning, what's an advisory. Is an advisory something like a watch or a warning? And so they want to keep the language simple. And so they'll have plain text. If there's going to be, instead of having a high wind advisory, you'll just say the winds are going to be gusty up to 40 knots or something, or 40 miles per hour over a particular area, as opposed to having that. So just a couple of interesting notes about some changes that the Weather Service has made. For our region, again, this is our meteorogram for the next 60 hours from 12Z this morning from the MM5 run we've been doing for the last almost 2 decades. And you can see, again, the trend in temperatures. You'll notice, interestingly enough, that the high tomorrow is going to be just a little bit cooler than the high today. And then we begin what looks to be a more robust warm-up. And we'll look at something that's using a special tool called an adjoint model. We'll get a sense of where that air is coming from that's going to give us that cooler weather over us, although we could have deduced it using other means. Dew points remain low. And again, it looks like a very nice dry weekend, as John was saying, with a big anticyclone over us that should keep us dry and relatively clear. The time height sections for this same period. Again, the yellow contours are the isotropes. And you can see in this map close to the surface, you can see that we're getting temperatures at the surface, at least in terms of this, mixing out to about 279 kelvins, almost plus 6 Kelvin for today. So perhaps getting the low 40s. Will probably be a little bit warmer than that. We can check the current obs to verify that. But then you see this isotrope is a little bit higher tomorrow, so we're not mixing down as deeply, but probably very close to the same temperature. You can see over our column, there is a little bit of a depression in the tropopause. The tropopause is relatively high, so it gets down to about 300 hectopascal by tomorrow early tomorrow afternoon. And you can see as that tropopause depression approaches, you can see the isotropes bowing up beneath that, which is sort of the classic configuration you expect to see with a localized potential vorticity maxima in a given region. Then the tropopause recedes out of this cross section, temperatures begin to warm up. And you can also see very broadly in the lower troposphere, this veering of the winds with increasing height to the extent that the winds are geostrophic. This is definitely a warm advection. And you can also see these tilt of these isotropes as time progresses toward the right on this diagram, indicating a warming occurring in much of the lower troposphere. So warmer weather coming up with this interesting little dip in the tropopause over us over the next 24 to 36 hours tomorrow. So tomorrow, the warm up is delayed. And as you looked at the weather map that John was showing, yes.
Can you go back to that meteorogram?
Oh, the meteorogram. Okay, sure.
Oh no, the time height section. Sorry.
See, you wanted to say that word. I know that.
No, I was just testing out if I could, because it's such a foreign sounding word. It's like a word from Welsh or something. Nobody should speak it.
Yes.
It looks to me like there's a stable layer from all the way from the ground. Of course, right at the ground when it's nighttime, it's obvious. But then it all the way up to the 288 Kelvin isotrope. It looks like is that stability in place, perhaps because of the anticyclone, and then this little disturbance that comes across just can't do anything to the air below 800 millibars. Do you think that might be what we're seeing there?
I think that's part of it. We're about to look at a horizontal map from the same forecast. I finally got those restarted, and we'll take a look at that. But yeah, this stable layer is an interesting feature. But yeah, this upper trough it's not a very pronounced dip, as we'll see in just a moment. So there is nothing, a significant upper trough like the one that's going across the southeastern United States today. That's a bit more prominent. This one is I think a weaker. It's just on the edge. It's a little wave propagating on the edge, and I'll show you that in just the next map.
The other thing is you can really see the warm air advection starting at about 0Z on the 7th, and you right up through a line that starts at the ground and gets up to about 800 millibars by 0Z on the 8th in the veering of the winds. There's a whole section of, all 9 or 10 columns that have that strong veering and getting to higher and higher elevation. It's really cool.
Right, and so Sunday afternoon, just by looking at this single chart, nice brisk southerly winds and warming up. It's not going to be toasty, but it'll probably be approaching maybe the upper 40s to low, maybe near 50 or so. And again, I think our snow cover is, as we were talking about yesterday, maybe depressing that warm up. At least we could be far warmer than we otherwise would be. Looking aloft on the 305 to 315 Kelvin layer, we'll first just start off with a current map. There's that little cutoff in the south central United States, that's moving east out. We'll see it moving eastward in the forecast, and you can see that really nice swirling large scale maxima and potential vorticity, cyclonic potential vorticity maxima over the eastern Canada, over Quebec, and The upper front shows up nicely as well. You can't really tell it's an upper front from just this map, but you see the edge, that nice strip of strong potential vorticity gradient that's really characterized around the entire periphery of this upper trough. So when you look at a dynamical tropopause map, you can actually see the upper trough in its sort of full glory, if you will, and a broad anticyclonic turning to the winds and low potential vorticity air over the western part of the United States. And so we're just, we're downstream of a trough, so you'd expect, fairly decent weather. But if the trough were moving out to the east, and then we would expect a warm up to occur. But we'll see in the forecast that this actually kind of remains in place. And I'll just animate this over time. So that broad swirling anticyclone for at least the next day or so. And you can see a kind of a contortion, a distortion of the upper potential vorticity that produces a small lobe to our northeast that comes rotating through. So maybe it's better to see that if I step through these maps. You can see this little bit of high potential vorticity air in southern Hudson Bay beginning to migrate around, rotate around, be advected around. This is at 0Z this evening. If we advance, I'll just do it in 12-hour chunks. Tomorrow morning, as it rotates around, it kind of gathers up a little bit of this potential vorticity from very high latitudes and brings it southward from Ontario into the northeastern part of our state. So this is just a glancing blow, and that's what appears in our time height section. It's just really the edge of this feature. Maybe it's one of these intermediate times. It just kind of goes through our area. There it is, the very edge of this, forming a nice, trough itself. This has some increasing curvature associated with it. But, and I think John's point now is even better taken. As this gets a little bit more organized, that stable layer may prevent much organization occurring in the lower half of the troposphere. This is all going to be occurring in the upper troposphere. But what it does keep in place is this rather chilly air over us. I think there's just enough ascent to keep things cold. But this broad ridge is beginning to develop with low PV air. Again, this is air that had its origins in low latitudes in the subtropics. And once it gets over us or just slightly to our east, we're going to see a nice warm up. Go up to 36 hours, so tomorrow evening. You can see that trough is now moved further to the west, or to the east, southeast. And you can see the increasing values of low PV aloft as the trough begins to recede. And we know at the surface, we have some fairly significant warm advection. And I'll go out to 48 hours Sunday morning. And that axis of really the low potential vorticity is just about on top of us at this point. But this is, again, air underneath it that's going to be more characteristics of lower latitudes. And I think we'll see a warm up in response to that. And finally, I'm going to go to 60 hours. So Sunday evening. Again, this is around the period when I expect that we're going to begin to see temperatures beginning to increase. I'll make this map a little bit larger. And again, nothing upstream of us, so this is going to be a nice pattern for us. Also notice the strong westerly winds that are now coming across the Rocky Mountains as this ridge continues moving eastward. That's going to be associated with some column stretching, but also the formation of a lee trough. And that warm air will eventually arrive over us. So even further warmth expected as we go into early next week. If we look at the 850 millibar, let's just step through the map at 850 millibar, starting with 0Z at this time. Again, you can see the chilly air that's over us. The advection is not really, there's some cold advection just north of Lake Superior, and we'll see that move southward, and that's going to draw in some colder air over us, but it's not going to be, again, it's not significant, going to be significantly colder tomorrow, but just as that upper trough rotates around, it'll get a bit chillier. And again, a nice cyclonic circulation in the southern plains associated with the surface cyclone. And we'll also see there's precipitation associated with that as well. I'll go ahead to tomorrow morning. Okay. Our temperature advections at this point, pretty much close to neutral. Okay. And still northerly winds at 850 millibars. So any mixing down that we get, if we could mix that deeply, is going to be constrained. And you can see the warmth beginning to spread across the Rocky Mountains, but not toward us. At 36 hours tomorrow evening, again, temperatures at 850 are beginning to warm as the ridge axis slowly begins to move closer toward us. You can see a nice broad area of warm advection occurring. Again, the flow at this level is not really direct. It's across the Rocky Mountains, but it's not a westerly flow, so that's really not going to generate much of a lee trough until the flow becomes more westerly. But over us, we can see the cold air is beginning to recede. And that was 36. And by the time we get to Sunday morning, okay, the flow has become much more westerly, and you can see that warm bubble, if you will, that begins to appear over South Dakota and northern Nebraska, just to the northwest of Lincoln, or northeast of Lincoln, northwest of Lincoln, and that's the warmer air beginning to spread eastward. And we'll get down to 60 hours in the forecast at 8:50, and see that again the flow becomes more southwesterly, but significant warm advection. We've warmed up considerably from temperatures that were below 0 at 8:50 to temperatures that are approaching 7 or 8 at 850 millibars. So significant warming occurring. And the big question is, how deeply will we mix? The days have gotten longer, so there's a chance for that to occur, the boundary layer mixing to occur, and that could get us into fairly much warmer weather by the time we get into early next week. Some limitations there, just looking ahead at this 60-hour forecast, certainly warm advection over us, but you can already see the arrival of a cold front through parts of South Dakota and central Minnesota. We'll have to watch the progression of that feature that could delay us warming up even more beyond this time period. Before we go to the longer range forecast, I wanted to just show an additional set of maps for you. And this is trying to look at the origins of the cold air that will eventually be over us by tomorrow afternoon. And so one way to do that, one tool that we might use to do that, is using what's called an adjoint model. An adjoint model propagates information backward in time. And if I have this set up correctly, we'll be able to see this. This is not particularly useful, but this box you see over here indicates the location of a lower tropospheric box that's centered over the state of Wisconsin. The domain we're looking at is similar to the domain we've been looking at for the other models. I'll show you something with a map background in just a second. And so what the adjoint model will give us some insight into is to where the air that's eventually going to be in that box. I'll just go forward to nearly the end of the forecast period to show you that map. If I have the right level selected. Sorry, tried to get this done earlier, but it crashed, so I have to rerun it.
This isn't GEMPAC, right?
This isn't GEMPAC. If it were GEMPAC, I'd be, these maps would be coming out in seconds. But I don't want to. Let me just make one quick adjustment. Again, I don't want to hold people up. I think it is kind of interesting, and it kind of tells a story. So this box, you can kind of see, this is 3 hours back in the integration. So how do we interpret this map? The response function, or the target function that I'm interested in, is the forecast for late tomorrow afternoon in terms of the average temperature in a box. This has been distorted a little bit because of the backward integration, but a box that looks very much like this. We're interested in 3 hours after this box. Where would you want to perturb the temperature forecast to increase the temperature in this box, which is essentially would be a measure of the average temperature over Wisconsin. And so you can use the adjoint model for variables like this, particularly when the flow is nearly adiabatic, to look at basically look at advection and transport processes to give you some insight as to where this air started from. So we take the model, we set up this domain, we integrate it backwards, and we ask the question, where is this air coming from? Where is the greatest sensitivity? If you could perturb the forecast at earlier times, where would you want to perturb it and by how much? So the blues on this indicate negative perturbations, the reds would be positive perturbations. I'm only going to show just a couple. I'll show more of this with a more refined set of tools next time. So this is for by midnight tonight. This is the air by midnight tonight. These are the places that if you were to change the temperature, or you knew that there was an error in the forecast, you can see what I'm tracing out. This would be the key regions where you would want to have, that would have perturbations, would have an influence on the temperature in that box that kind of surrounds Wisconsin by late tomorrow afternoon. So this is just really 12 hours from now. This is where the air is going to have its origins over, that will end up over Wisconsin by late tomorrow afternoon. If I go back just a little bit further in time, And if there are questions, I'll be more than happy to address them. I know this is being presented rather quickly. And I'll get back to the forecast in a second. This is by tomorrow. This is by this afternoon. At this particular level, you see very little sensitivity. So the air that's going to be arriving over us, so this afternoon, these are the places at this particular model level where you would have the biggest influence on temperatures at this level. And you have to really, again, this is sort of fresh off the presses. You have to go up a little bit further in the atmosphere. So some of this air is actually subsiding a little bit, if this shows up. So there you can see these sensitivities are higher, indicating that at a slightly higher level tomorrow, but later this afternoon, this is the air that will be over Wisconsin in 12 hours from this particular time. If I knew my forecasts were too cold in these regions where you see the red, that would indicate that I would actually have a lower temperature expected over Wisconsin by tomorrow afternoon in these red regions. In the blue regions, if I knew that the temperatures were too warm, that would also lead to a colder temperature in that box 12 hours or 24 hours from this particular time. So this gives us an idea of the source regions for air in the atmosphere, air in a forecast in terms of temperature. You can also use it for more dynamical variables like wind, temperature vection, the intensity of a cyclone, what are the sensitive regions for a cyclone intensification or weakening. And this is just showing a very simple variable, the average temperature in a box over Wisconsin. But I'll show some more of this later and have some more refined graphics than this crude display that I've just shown you. Again, any questions, I'll be happy to address it. All right, let me get back to our forecast. So cold air, the origins are north of us. We saw that the flow was from the north or northwest. This kind of is not too surprising. So this adjoint application isn't the most surprising, but it kind of gives you some sense of where to look specifically in a targeted fashion for the source regions for air over a particular region. And this is the animation of the sea level pressure and precipitation. And again, you can see a rather dry weekend over us. The disturbance that was over Texas continues moving eastward and then actually develops into a cyclone just east of Florida over the weekend. But for us, you can see initially the cold advection, you can see the thickness contours backing into us briefly and then beginning to recede as that cold air begins to move out. Again, this loop is over 60 hours. And you can see that cyclone that moves across Manitoba and Saskatchewan is dragging with it that warm air off the Rocky Mountains to the east of the Rocky Mountains with it. And so we'll be in that warm sector at least for the day, late on Sunday into Monday. What about beyond that time period? So it's 60 hours in the forecast. This is on Sunday evening. You can see this is the GFS forecast. You can see that warm advection is broadly covering a good from the southern plains all the way up into the Great Lakes region. Nice, strong, warm thermal advection. This is going to be portends for a pretty decent weather in terms of temperatures. This is 0Z Monday, so Sunday evening at 6 p.m. And we still have that chilly air over us. This is only forecasting a temperature in the upper 30s to low 40s. I suspect I've seen that the models have been too warm. If you take just the raw model output, this has been a little bit low with the temperature forecast. In fact, if we look at the statistical output this is for the GFS, after a low of 21 tonight, tomorrow 44 for the high temperature, and then 21 tomorrow night, and then Sunday getting up to 49. So this is much different than what we're seeing from the raw output of the GFS, and then an overnight low Sunday night into Monday that's going to be above freezing. So our melting will continue significantly. You can see also the probability of precipitation, very low. And in terms of cloud cover, generally clear, maybe a few clouds on Sunday. It looks like broken, scattered clouds during the afternoon on Sunday. But again, really nice weather. And the precipitation type, most likely precipitation type, snow obviously at the beginning of this period, but as the warm advection takes over and the column gets above freezing, rain would be the most likely outcome. Looking beyond that time period, so we see 44 for Saturday, 49 for Sunday. This is for the extended GFS forecast, some of the MOS. And at least the model from 12Z today is suggesting and 55 on Monday. Again, this has been a little bit cool. And then maybe breaking into the low 60s as we get into Tuesday and Wednesday. And there's some issues there. One, with the snow cover, there is also ice. Not ice, excuse me. There is overcast. And so the cloud cover is going to also play a big role, and the likelihood of some precipitation. Those numbers are going up as well. So let's look at the actual surface maps and look at the progression of features beyond that time period. So dry through Sunday, Monday morning. And the crest of that first burst of warm air, the thermal ridge axis is to our south, at least in terms of thickness. And any vestiges of sort of a cold front are pretty indistinct, maybe just slicing through the northern part of our state. If we go ahead to Tuesday, we see a resurgence in the warm air advection at this point, and again, still dry. So that's maybe a potential day to warm up to 60. I don't know, John, you seem to have some uncertainty with, or not uncertainty, but you don't think it's going to get that warm. Is it just because of the surface?
I'm afraid so. Yeah, I think it's just the snow. It's nice to know we'll have a Sunday night melt. It looks like temperature will stay above freezing, but and the air is dry, so that's helpful as well. But I just don't know if we're going to get rid of it by Monday night into Tuesday. And if we don't, I don't see how we get to 60. I hope we do, but I don't know if it's going to happen.
Right, but I think the 850 temperatures, I didn't look at this carefully. I also think the thicknesses compared with a week ago, I think we broke 50 for the first time last weekend.
Yeah.
Are going to be far higher than they were. The ones coming up are going to be far higher than they were last weekend. So I think we have a possibility of getting much warmer.
If we do, and it's still snow on the ground and we see 60, that will be pretty remarkable. So I hope it happens. I'm holding out hope.
Yeah, this is this is just the raw model output, and again, it's had some issues, but this is 12Z on Wednesday morning.
Man,
temperature 54.
Wow.
Over us. So again, this is consistent with getting close to 60, upper 50s by 18Z, and low 60s perhaps by this time period. At the surface, again, still warm advection, but probably have clouds and some precipitation. So those are going to be factors that may keep us just from really maximizing the warmth. So I think the two things going against us will be some cloud cover, lingering snow, but certainly the temperatures aloft and just above the surface are going to be some of the warmest we've seen. Again, without snow cover, I think would easily be in the 60s, but that may put a brake on us.
Yeah, and it's going to be windy too. I mean, even peering through the 2 millibar contour interval here, you can still see it's going to be pretty windy.
Right.
And that's going to help to mix it, like you're saying, get some of that warmer potential temperature air downward. So even with clouds, so that's possible. It's going to be interesting.
Yeah, 850 temperatures on that day, pretty decent. I mean, that's 9 degrees, and you want to add about 12 to that. So I mean, if we had a nice dry day, no snow cover, I know these factors don't exist, we would be probably in the around 65 to 68.
Yeah, an outside chance of 70. I think you're right.
That'll come in another month or two. So
67 days. That's what we want. That way we can break a record. I don't want that. I'm kidding.
You don't want that? Oh, come on.
No, that's not a record I want.
All right. And then just to round this out, because I know things are getting a little bit short. Our warmth is going to come to an end, with the passage of a cold front. And it could even be with some thunder and lightning, sort of a convective event going through. So that'll be interesting, I think, for the discussions in 453 as the potential, not necessarily for severe weather, but for some thunderstorms organizing along this front. That's going to be interesting. But then that puts a brake on our warm up. So that a week from today, fronts cleared us, but we're back into a slightly cooler weather regime, but still sunny. So that's a nice benefit for that. And as I just step through this very quickly, I'm going to jump ahead to 10 days. There's some signs of a fairly significant cyclone mid-continent that could go from rain to maybe actually a little bit of snow before it ends. So, John, it's not over yet, unfortunately.
Beware the Ides of March. Here we are, Caesar.
Yeah, well, this is the Yeah, I guess this is the evening, not in GMT, of the Ides of March. That would be an unfortunate event. Sort of like, winter is stabbing us in the back, you might say. You too, winter. Are you going to do that to me? So, and then we get, this is getting into fiction land, but a big sprawling 1043 high over us. That's not fun. No one wants that. Looking ahead, and that gets us back into daytime temperatures in the low 20s, which would be unfortunate. So
with bare ground, which is the worst possible set of circumstances.
But the sun angle will be high, so it'll feel warm, right, John?
That's true. That's true.
So again, for the weekend, kind of temperatures remaining relatively steady. The high temperature today will very much likely be repeated tomorrow, maybe a degree or so colder. Then beginning to warm up on Sunday, not significant. Monday, a little bit warmer, a bit of a pause. And I think Tuesday and Wednesday are our biggest shot to get into the middle to upper 50s. 60 does not seem possible, although the model's suggesting that. We'll look back next week and see what happened with that. But really pretty quiet weather, and then things kind of turn around with the passage of the final front on Thursday, and cooler weather back for next weekend. So thanks, John. Thanks, Pete, for setting this up.
Thanks, Pete, for setting it up, and thanks everybody for attending. We'll see you all next week.
All right. Thanks, everybody.